Hi students, let us continue with the scheduling algorithm. So far we have discussed about the first come first serve, and the second one is shortest seek time first. Now coming to the third scheduling algorithm, that is a scan. So in the scan disk scheduling algorithm, the arm moves in one direction only. So far we have seen that first come first serve means the first request that whatever that is served, that has to be served first, that has to be served first. In the shortest seek time first, the shortest seek time compared to the means from starting arm to the next arm, so the arm that has to move, which track is having the shortest seek, that track has to be visited first, that is SSTF. Now coming to the scan. The scan, here the arm moves in only in one direction only, and satisfying all outstanding request. Until there is no more request in that direction. Okay, suppose the arm is moving, suppose here this direction, it has to serve all the outstanding request, whatever the request that it wants to serve, that has to be served. Okay, until there is no more request in that direction means until the end also it has to be reached. If it is going in one direction, it has to reach until the end of the track, end of the disk. Okay, the disk contains number of tracks. Okay, until the end of the track it has to move and come back to serve the remaining, if there is another any requests that are pending. So the arm moves in one direction, so either this direction or this direction. The arm moves in one direction only, satisfying all outstanding requests until there is no more request in that direction. So until there is no more request in that direction, that you call it as a stack. So the service direction is then reversed. So once it is reached the dead end position, it has to move back. Service direction is then reversed. So the service direction is then reversed. First serve in one direction and next it should be reversed. So this algorithm works like an elevator. It works like an elevator. So we also call it as an elevator algorithm. Why I am calling this scan as an elevator? Suppose a lift was coming. These are the different floors. Okay, different floors. So once the lift was coming from this position, so in this is floor to ground floor. So first it reaches to this floor. If whatever the request that the floor is, suppose this is 0, 1, 2, 3, 4 like that. Suppose this first floor is requesting and the second floor is third floor is requesting, and the arm is in this position. So first it serves the third floor, next it serves the first floor. So it will reach until end of the floor, even though the 0th floor is not requesting. Okay, the ground floor is not requesting, it reaches until the end direction, because once it go back, it doesn't come until it reaches the previous, means the before request. So just like an elevator, it is moving from only in one direction, either in this direction or in this direction. Only in these two directions the elevator will move. So that's why we call it as an elevator algorithm. So the advantages in this scan are high throughput, low variance of response time, and average response time. These are the advantages of using the scan algorithm. Then coming to the disadvantage. The main disadvantage here is only the long waiting time. The long waiting time for request for locations just visited by disk arm. So the long waiting time for request for location just visited by disk arm, what it means? Means suppose here we are in suppose 5th floor. Okay, so in the 5th track. Now the we are moving in this direction. So just we start from 5th. So we are moving in this direction. We reached the 4th. Now suddenly the 6th will come. The 6th request will come. So rather than serving the 6, it next serve 3, next 2, next 1, next 0. After that it goes back. Again serve the 6. Means this 6 has to wait a long time, even though it is just visited. Even though the 5 is just visited, it has to wait until her task come. Means a long waiting time for the 6. A long waiting time for the request for location just visited by disk arm. So that is the main disadvantage in scan. Now let us see the example so that you can understand. Example, the same example I am taking. A disk contains 200 tracks. That is from 0 to 199. And next the request queue. The same queue I am taking. The request queue contains track numbers 93, 176, 42, 148, 27, 14 and 180. These are the requesting queue contains the track numbers and the current position of arm. Read-write head. Of read-write head I am taking as 55. The arm position was 55. Now I have to calculate the total number of tracks movement by read-write head using scan. Okay, so first we have to decide the direction, whether we are moving the forward direction, means we are calculating the larger values towards larger values or towards the smaller values. Now let us take the direction moving towards larger values. So in the scan only you have to be decide starting only scanning, or scanning the larger values or you are scanning the lower values. So that has to be decided. Moving towards larger values. Let us take this. So the disk contains starts with 0 and the track ends with 199. So the current position of read-write head is 55. So from 55, the disk has to move towards the larger values. So the 55 next larger value is 93. So 93 is somewhere here. So it moves to 93. So after 93, what will be the larger value? 148. So 148 is somewhere here. So 148. Next larger value is 176. So 176. The next larger value for 176 is 180. So after that, so even though if it reached 180, it has to move to the end position, end of the track. Because suppose if we move back, suddenly this means only the track contains only the less number. So it's better to move until to the end of the track before going to backward. Okay, it's suppose to overcome the waiting. Okay, to overcome the drawback of this waiting, you just reach the last number in the track. So 180 to 199 means scan moves up to the last point. So this is the only difference thing you have to be remember. The scan has to move until to the last point in the track while it is moving backwards. It has to, because once it go back, it has to reach to this point. It takes lot of time. Means coming this way, again coming this way, means it takes lot of time. So it better to move to the end position. Means it will checks whether there are any person is still waiting. Means any track is there. Any track comes before while we are starting with in the queue. Okay, so just check, means reach to the end position. Now after 199, it moves to the 42. Next 42, it should be 27, and the last one is 14. So this is how the scan will be done. So the total means the total number of tracks movement by read write head using the scan is, so this is one direction and this is another direction. So just calculate this. So 55 to 199. So 199 minus 55. So this is one movement, the arm in one direction, and next this is another direction, means plus 199 minus 14. So you will get 329. The total number of track movements by read write head is 329 by using scan algorithm. Thank you.